we want to review the concept of wildcard generics again. So we said we have two stacks. We want to push a stack, string, and object. So they are different type. And we want to add combine stack 1 into stack 2. Now add pretty much just looking at T as the same type. This is different type. What we call add, it will complain as object and string right there incompatible type. So they will not allow. But how we gonna fix this? We said since we know that we can do question mark wildcard. So that stack 1 question mark it could be string, it could be any type. Right? It doesn't have to be string, but now we said it could transform the second stack type, which is T type object, right? So in that case, hey, string extends object. So stack 2 is object 2. Then we can push object into object. That's no problem. Then we can run the program and no errors. Now what happens if we know this is going to be a problem because different type. What happens if I say instead of stack 1 question mark extends T, we said how about stack 2 question marks extends T. Alright, let's look. Stack T now is going to represent string, right? And string is a question mark is going to represent object, right? Object extends T, that makes sense? Object is not a subclass. Let's say object is a subclass of T. Object should be a super. So that's why I started to complain here, right? That no instances of type exist so that object conforms to string. No, right? So inference variables T has incompatible bounds, equality constraint string, lower bounds object. See, lower bounds could not be object, right? So that means we should use another generics type. What is it? Lower bounds, right? We have lower bound generics. We have unbounded, which is just T cell. Bounded is T extends, right? Or question mark extends T. And lower bound is super. We said, hey, actually, object is a super of string. Right before it said object is extends from string. No, object is a super of string. Then this should work. So no problem. We run the program is running and no problems. So that's the point of the using wildcard generics, right? You can either do this way, question super T, then you can make T as the string type and still allow us to push combine stack 2 into stack 1 to stack 2. Alright, so now we understand the generics concept. We come back. So that's why this chart say, hey, whenever I say E, right, super of E, that's a question mark on the top. Extends from E, that's the bottom, right? Object, of course, everything is going to be extended from object. If I do unbounded, just like that, question marks, right? E is always some superclass, E some subclass. Let's review this. Question mark, yeah, it can be any object. Question mark extends B, right? And this is A, B, like question mark super B, this is a B subclass then, right? Then that's super of B. So what happens if line 12 to 13 are changed from, if I do question extends t, stack 1, so and t, we just seen it, right? This should be okay too, right? Because we say string extends from object. That's fine. There's no errors. Let's look at it again in case you don't see. Instead of doing this way, we say question extends t and do the t. This is what it say here, right? And that should be okay when you run the program. Right. So what happened if we do also say super t, if we do both? Still okay, because they are correct, right? But not the other way around. Erasure and restrictions on generics. The information on generics is used by the compiler but is not available at runtime. This is called type erasure. Generics are implemented using an approach called type erasure. The compiler uses the generics type information to compile the code, but erases it afterward. The generic information is not available at runtime. This approach enables the generic code to be backward compatible with the legacy code that uses raw types. So the legacy code, like we said, they don't use generics, they just use object. So the generics are present at compile time. Once the compiler confirms that a generic type is used safely, it converts the generic type to a raw type. For example, the compiler checks whether the following code in A, so we say string here, so check A, string, right? So say, use generic correctly? Yes, it's correctly because it's string. Then translate into the equivalent code in B. Alright, so it's going to translate into just raw type, right? After that, it's just convert to raw type. In order to make it compatible with the legacy code, right? And it's cast string when it's do get. Before we don't have to cast with the generics, but now we have to. So we just translate code, right? For runtime to use, the code in B uses the raw type. So this is called type erasure, right? So information trick is used by the compiler, but it's not available at runtime, right? The compiler uses the generic type information to compile the code and say, hey, this passed. Then erase the information afterward and convert into the raw type. So at runtime, it's no longer available. It's going to be raw type, right? In order to support the backward compatibility with the legacy code. Again, if the question asks you what's type erasure, you can answer it's not available at runtime, right? The information of the generics, because it gets converted to raw type in order to support the legacy code. Replace generic type. When generic classes, interfaces, and methods are compiled, we know that generics can be at the class, at the interface, and at the method, right? Levels. We can make interface as generics, make class as generics, and method as generics. The compiler replaces the generics type with the object type. Okay. So we say replace generic type with the object type. For example, the compiler would convert the following method. Let's say in A, this is the method, right? Generics method. we use E to declare after static variables. It's going to convert into object array now instead of E generates, because it's going to replace generic type. Okay, and replace bounded type. So we talk about bounded generics when it extends geometric object class. If a generic type is bounded, the compiler replaces it with the bounded type. Like when we compile, right, the compiler would convert the following method into, so there's no, the generics bounded, right, but it's going to be use that type instead, geometric object instead of E. So this is called replace bounded type. So important fact, it is important to note that a generic class is shared by all its instances, regardless of its actual concrete type. Support list 1, list 2, they are string and integers, right? They create as follows. So array list, string, array list, integers are two types at compile time. Only one array list class is loaded into the JVM at runtime. List 1 and list 2 are both instances of array list. So the following statement display true. So list 1 instead of array list, list 2 instead of array list. However, the expression list 1 instead of array list string is wrong, since array list string is not stored as a separate class in the JVM. Using it at runtime makes no sense. So that's why I say array list is shared by all its instances, right? Or the generic class is shared by all its instances, regardless of its actual concrete type. So they all just array list. They're not depending on the concrete type. Because at runtime, we don't have the concrete type. They're all raw type. Right? Because generic types are erased at runtime, there are certain restrictions on how generic types can be used. So let's look at restrictions. We cannot instantiate an object like with the E type like that, new E, no. E object equals to new E, no. You cannot create an instance using a generic type parameters. The reason is the new E is executed at runtime. Generic is for compile time, not runtime. And the E type is not available at runtime. You can also not be able to use to instantiate, like create an array type E. So as a type parameters. This is wrong. You can do a type in front, but you cannot do E like that, right? You can circumvent this limitation by creating an array of the object instead, like that. Type as E, like I said. And then you have to cast an object to an E array type. So when you do array, you have to E brackets like that. However, casting E causes an unchecked compile warning. The warning occurs because the compiler is not certain that casting will succeed at runtime. For example, if E is string and new object is an array of integer object, you cast it to string will cause a class cast exception because different type, right? So this type of compiling warning is a limitation of Java generics and is unavoidable. So we cannot avoid anything about this one. Generics array creation using a generic class is not allowed. So you can't say array list, string array of list like that. So create an array which is array list contents in array. The type concrete, you cannot do that where you have to cast them, right, in order to prevent the compiler errors. Because at runtime, the concrete type is no longer valid.